Okay, part 2, chapter 10, homework, AP stats. We're doing number 5 this time. So the first problem is the natural log of y equals 1.2 plus 0.8 to the x. So what you want to do is solve for y hat. So the easiest way to do that is to put it into exponential form. So this is the natural log of y equals 1.2 plus 0.8x. So the base is e, the product is y hat, and the exponent is everything on the right here, 1.2 plus 0.8 to the x. So this can be rewritten as e, because that's the base of the natural logarithm, e raised to the power of 1.2 plus 0.8x equals the product y hat. Okay, so the base e goes here. We're going from log form to exponential form. Everything on the right is the exponent, because what a log equals exponent. So this is the power right here, 1.2 plus 8x. This is the power that e is raised to in order to equal y hat. So we put it in exponential form. We get e to the 1.2 plus 0.8x equals y hat. We plug in 2 for x. We get e to the 1.2 plus 0.8 times 2 equals y hat, and y hat is approximately equal to 16.4446 or whatever. And here's the calculator move. Now let's just go over that quickly in the calculator. What is that going to look like? How do you do that? Second, and then ln, okay, and that gives you e plus an exponential up arrow here, or caret, or hat, or whatever we want to call it. And we put in 1.2 plus 0.8 times 2. And we'd enter, and then we get our answer. Okay, so that's A. Now B we have the square root of y hat equals 1.2 plus 0.8x. So again, the strategy is to get y hat all by itself, get one y hat. So to do that, it's pretty simple. We square both sides. So we square the square root, and that gives us y hat. And so we have to square 1.2 plus 0.8x added together. We plug in 2. Y hat equals 1.2 plus 0.8 times 2 squared. Y hat equals 7.84. And this is fairly easy to do on the calculator. There's nothing mysterious here. Just put them in parentheses, add them together, and square them. Okay, C, 1 over y hat equals 1.2 plus 0.8x. Okay, so let's think of the left and right side both as single fractions. So the way we can do that, we got 1 over y hat on the left, so that's a fraction, obviously, equals 1.2 plus 0.8x over 1 on the right. Now we're doing this because we want one y hat. We don't want one y hat in the denominator or anything like that. So if you have a fraction equaling a fraction, then the reciprocals equal each other. So y hat over 1 equals 1 over 1.2 plus 0.8x. So then this becomes pretty simple to evaluate. Y hat equals simply 1 over 1.2 plus 0.8 times 2, which is 0.3571. Okay, D. Y hat equals 1.2 times 0.8 plus times the ln of x. Well, this is pretty straightforward. No transformation is needed. God bless you. 1.2 times 0.8 times the natural log of 2. Just plug in 2 for x. And just put in the calculator 1.2 plus 0.8 times the ln of 2. You don't even need to do any algebra on that one. And it's about 1.75. Finally, E. Okay, this one's a little more complicated. Natural log of y hat equals 1.2 plus 0.8 times the log of x. Now there's some simpler ways to do this, I suppose, but let's do a little bit of algebra here so we know what's going on. Okay, so let's take that 0.8 in front of the log of x and make it the exponent of x. Okay, now this is a product property from logs. The coefficient of the log can become the exponent of the product. So we're taking 0.8, being the coefficient of the log, and making it the exponent of the product. Now, I'm not going to go into the proof for that. You got into that in pre-calculus and and algebra 2 and all of that. But anyway, just take my word for it. It does work, and there's a proof for it, and it's pretty straightforward. Okay, so now we have the log of y hat equals 1.2 plus the log of 8 to the point x. Now I'm going to subtract the log of 8 to the point x from both sides. I get log of y hat minus log of 8 point x equals 1.2. I can now use another product property. If you have two logs with the same base, they're both base 10. The base is not explicitly expressed, so it's base 10. Then you can re-express these two logs as a single log and with the products as a quotient. So the log becomes a log of y hat over x to the 0.8 equals 1.2. Now we're going to go to exponential form. So the base is 10, the exponent is 1.2, and the product is y hat over x to the 0.8. So 10 to the 1.2 equals y hat over 10 to the 0.8. Multiply both sides by x to the 0.8. Multiply both sides by x to the 0.8. You get 10 to the 1.2 times x to the 0.8 equals y hat. Y hat equals 10 to the 1.2 times 2 to the 0.8. Plug in 2 for x. And you get 27.59. And here's the thing right here. There's really nothing mysterious about that calculator operation. Okay, now what did we end up with here? We ended up with what's called the power function, where you have y equals a times x to the b, where x is raised to some power, and a, the starting point, is 10 to the 1.2. Earlier, I think in the first problem here, we ended up with the exponential form, where x is an exponent. Y hat equals e to the 1.2 plus 0.8x. So when the log is being taken of y hat, then you end up in the exponential form. When the log, like in D, is just taken of x, you're just in log form. And when you have the log of both sides, you end up with a power equation, where x is raised to some power, like y equals x squared is a power equation. And that is that.